Hi, today we're going to take a look at a calculus topic called limits. Now, limits are very easy to work with and they're very easy to understand. An example is, let's look at this function right over here to the right. Now, the first question says, what is the value of a function? Now, that's something that we all know from Algebra 1. If I want to find f of 0, I look at it. It's 4. Very easy to do. But the second question, this is the hallmark of all of calculus. Not what is the value at 0, but what's happening as we approach 0. So if I'm on the function, either way, if I'm approaching x equals 0 from the left and from the right, as we're approaching 0, what is my y value approaching? And that's what we're looking for. What is the value of the function approaching? So if x approaches 0, so in other words, as we go close to the 0, my y value also approaches 4. So we say this, that the y value approaches 4. It doesn't equal 4, it's approaching 4. And that right here is what we call a limit. And that's what we're going to talk about right now. So, as you notice, these are two different questions here. One deals with the value, and one deals with what we're approaching. So the first question deals with what happens if at x equals 0. The second question is not asking the value, but rather what the value is approaching as x gets really close to 0. We call this a limit. And limits help us to understand the behavior of a function as we approach a certain number. Now, let's take a look at another example here. Now, same as before, what's the value at 0? Now, the value at 0 this time, be careful, that's filled in, that's a hole. The value here is 2. But now what's happening as we approach 0? Well, for this one, we have to look at opposite sides because it depends on what side we're entering. This one depends on direction. Now, most of the time we have to look at the direction. If we come in from the left, for instance, if we approach from the left, as we approach x equals 0, we're approaching a y value of 2. So we're saying y approaches 2. And we use this little arrow right here to mean approach. If we approach from the right side, now we're going down, but we're not approaching 2, we're approaching the hole. And the hole has a y value at 3. So this one approaches at 3. Now if you notice, here up top, from the left and the right, I'm approaching the same number, 4. So we say this has a limit of 4. But down here, from the left I approach 2, from the right I approach 3. These are not the same. Now that becomes important for us because we say in this case that the limit does not exist if they're not the same. We're going to talk a lot about that in just a few moments. Now, notice that the value and the limit do not both have to exist. See, this one has a value, this one does not have a limit. But if they do, so in other words, if the value and the limit are, if they do exist and they are both the same, so in other words, if the limit and the value were the same, then we say that the function is continuous. And that was our first example. See, up here the value was 4, the limit was 4. Therefore, this is continuous. Down here, this is not considered continuous because the value is 2, but the limit itself doesn't even exist. So therefore, we would say this one is not continuous. Now, continuity, as we call this, is a very big topic in calculus, and we're going to spend a lot of time on that. So let's go on to the second example. Let's take a look a little bit more about the definition of a limit and how we write it. Now, we have a special notation in this right here. The limit as x approaches a of f of x. That's our notation, and it's read the limit as x approaches some number a of f of x. What we're trying to do is we are finding what y approaches. That's the whole goal. Ideally, we want the y value to approach the limit to approach the y value. Sorry about that. So, rules for existence. Now, this is the most important thing right here. This is all you need to know about limits. The rule for a limit, we need both sides. We need to take what's called the left hand and the right-hand side. Now, the left-hand limit, we have this little minus sign right there. It's a minus sign, and that means left. On the right-hand limit, it's the same idea, but this time we change it to a plus sign. That means we're coming in from the right. So you have the left, you have the right. They're heading towards each other. Now, for a limit to exist, we say that the left must equal the right. It's a car crash. They need to crash. The left and the right must equal each other. Now, over here, there's kind of a typo here. These should all be -4s. So -4, let's make this a -4 to the left, a -4 to the right, and a -4. So, for question number 1, we're asked to find the value at -4. There it is. There's the value. It's the 1. Be careful, that's a whole, not a value. It's a whole. The value is right here, and the value is 3. Easy breezy. Now, for question number 2, now we get into our limits. And in this case right here, because of the minus, we're looking at a left-hand limit. So now what we're going to do is, we're approaching -4, but we're coming in from the left. So, as I come in from the left, what's my y value approaching? And you can kind of trace along the graph if you want to. We're approaching the y value of 3. Very easy to do. Now let's take a look at number 3. Now we're approaching it from the right. So I'm approaching -4 from the right. Now if I'm on the function, let's see what happens. Oh no, I'm not approaching 3 this time. What are we approaching? 4. So my left and my right, these are not equal. Now that means something for us, because when we get to part 4 here, it's saying, what is the limit as x approaches -4? This is actually saying, what's the actual limit? Now, the left-hand limit exists. It's 3. The right-hand limit exists. It's 4. But to get the actual, we say that the left must equal the right. But what's the problem here? The left and the right don't equal. So therefore, this limit does not exist, because my left and my right are not approaching the same number. And we can say it this way. The left hand limit does not equal the right hand limit. Okay? For now, when we get to calculus, we're going to talk about a way more formal definition. Matter of fact, we're going to see that in just a little bit as well too. But for right now, that's okay. That's what we're saying. The left and the right don't equal each other. So let's take a look at number 5 here. What's the limit as x approaches -1 from the left? Here's -1 from the left. As I approach -1, be on the function. That's not the function. That's just a random point. Be on the function. There. What are we approaching? A y value of 2. As we approach from the right, this way, again, don't want to be here. Be on the function. From the right, we're also approaching 2. So take a look here. Does the actual limit exist? We did the left, we did the right, and notice in this case, they are equal. So if I want to take a look at the actual limit, will it exist? Yes. The actual limit does exist. Because the left and the right equal each other, we say the actual limit is 2. We're approaching 2. We approach 2. Now, but why do we say the limit exists? And we say this, because, and here's how we write it formally, the limit as x approaches -1 from the left of our function equals the limit as x approaches -1 from the right of our function. And that's what we put down there. This is our formal reason. And we're going to talk a lot more about this tomorrow, okay? Now, let's take a look. What is the value at -1? That's this random point here. And it, of course, is just 1. Easy breezy. Alright, so let's take a look at number 9. Now, number 9 says, is the function continuous at -1? Well, remember we talked about, for continuity, 2 things have to be true. 1, you have to have a limit. And we have a limit at -1. It's 2. We also have to have a value. We have a value. It's 1. But what we say is that the value... So another more important thing that we say is that the limit must equal the value. And do they equal each other here? Here the limit is 2. The value is 1. So they're not equal. If they're not equal, therefore, we say it's not continuous. And the reason for that, the limit does not equal the value. Ran out of room down there. Sorry about that. So let's try another one here. Matter of fact, what I would like you guys to do, try 10 through 14 on your own, and we'll go over these as a class tomorrow, okay? And then go on to part 2.